Oh wait, I'm in C++. Maybe this is something I know in Java. Oh, it was just an array of ints. Okay, let's go back to that first one I clicked then. I was getting worried. I never heard of a vector before. Okay, we're back to this problem number 26. So let's read this and then we'll get a solution going. So given an integer array called nums, that's my only input. This array is coming to me sorted in non-decreasing order. Okay, so ascending. Remove the duplicates in place such that each element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Oh, that seems simple. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. So I do need to alter the nums array. Change the array num such that the first k elements of nums contain the unique elements in the order they are presented. Oh, okay, so I'm moving things around inside the array. Gotcha. Okay. And then I'm just returning the count of unique nums. Okay, so what am I going to need? Of course I'll need a for loop going, so let's get that started for int I equals 0. I is less than nums.length I plus plus. And we're going to want a counter for the unique digits, so integer int counter. Let's call it int unique. Wow, unique digits. And that will begin as 0. And let's return that down here. And then I'm going to need something to help me swap things around inside the array. Yes, so I'm going to need, it's an array of ints, so I'll just need an integer called swap to hold that temporary value. And then I'm going to want, I think, another integer keeping track of which index to put the new value in. So non-decreasing order, these are ascending, yes. So this will be called int last index. And it needs to begin at 0. Maybe it needs to just go to 1. We'll find that out in a second. So let's get inside the loop here. Oh, wow. And let's call it int. We're going to need int x to work with here. So at the very beginning of this loop, let's say that x equals nums at 0. So the very first thing in nums becomes x. Nope. That's not how that's going to work. Wait a sec. Do I need a nested loop? I don't think so. Int x. Maybe. Yeah, let's declare x to equal num0 up here. So we're going to start with that. And then we can actually skip the first thing there. Can I get an empty array though? Yeah. let's just set up this case. If nums dot length equals 0, let's return 0. So I don't have to worry about an empty array. And then now here we can go in. So what we need is to know if the second number equals the first. So if nums at I, which will begin at 1, equals x. So if that is true, then we have a repeating character. If we have a repeating character, we are going to continue and do nothing. Else, so if, let's say, the second element at index 1 is not a repeating character, we're going to want to do a few things. We're going to want to increment unique digits, which actually should be 1 since we're starting with that very first thing at index 0. So unique digits will be incremented by 1, and then we need to perform a swap. So we need to swap, let's set swap equal to nums at last index plus 1, last index plus I. Maybe this should be 1 too. I don't like how I'm setting things in advance, but swap equals nums at last. I see what's throwing me off because it's the second character. Let me imagine it's the fourth character. So if I is now 3, if the third index is a unique digit, then we need to put that at the last index variable, which is currently 1. So swap equals nums at last index. Maybe I should call this current index. That's throwing me off. Current index. Swap equals nums at current index. And then nums at I needs to equal nums at current index becomes nums at I, our unique character, is being swapped into the front of the array based on the current index variable, and then nums at I, which is currently 3 in this example, becomes swap. Swap equals nums at current index. Nums at current index equals nums I equals swap. So that swaps them. I'm seeing something that will cause wait a second. The remaining elements of nums, it looks like the order they're in does not matter. I need, if I have a 1, 1, 2, 3. No, if I have a 1, say I have 1, 1, 2, 2, 3. So 1, 2, 3. I'm thinking that if I swap a number further down the list, I'm just kicking the ball forward and it might get added back into the list. Whatever x is, if it encounters a number less than it, that number should not matter. So okay, if nums at I if a number at some point in my list is less than or equal to x, then I should do nothing. Otherwise, I can do this, but do I need to change x here? Oh, we could change x at the end. Here, x could then equal nums at I. Yes. If it's an empty array, return 0, 0 unique numbers. Print I equals 1. I really want to press the test button, but I feel like I've lost track of something here. Let me get a piece of paper. Maybe a notepad would be better, so it's recorded. So let's say I have an array 1, 1, 2, 2, 3, 4, 5, 5. So at the beginning, x equals 1, and unique equals 1, current equals 1. So the loop runs, I equals 1. What happens? On the first loop, if nums I equals x, which x is 1, nums at index 1 does equal x, we're looking at this number, then we continue and skip everything. And then x equals nums at I, so x stays 1. And now, so nothing happens. When I equals 2, if nums at the second index equals x, so the x is currently 1, nums at I, third index is 2, so we're going to go into the else clause. So if nums of I, so if 2 is less than or equal to x, which it is not, we continue. Else, unique digits gets put up to 2, plus 1, swap becomes nums at current index, so current index is currently 1, so swap becomes 1, nums at 1 becomes nums at I, which is 2, so that becomes 2, and then let's do it like this, 1, 2, 2, and then nums at I, which is currently 2, equals swap. So nums here to 1. Makes sense. And then x equals nums at I, which is currently 2, x equals one. But I think it should be x should equal whatever is at current index now. So that would actually equal 2. And then let me just do one more iteration. I equals 3. what happens? It's another 2. So if I equals x, which is 2, continue, so we skip all this, good. X continues to equal what it already does. And then we get to 3. If I equal x, it does not. 3 does not equal 2. Else if I less than or equal to 2, it is not. 3 is greater than 2. Then we do this. I think it all works out. Let's test it. Boolean cannot be converted to int. Where did I do this? Line 17. Oh. What did I do that for? Zero, 4. Okay, so this one was incorrect. So 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. 0. Got the 0. And then what happened on the next iteration? Let's see what I got for unique digits. I did print out 5. So it is correctly counting unique digits, but something in the way I'm swapping it is incorrect. Swap equals nums at current index, which is 1. Nums at 1 equals nums at I. Be 1. Nums at I equals swap. Oh, wait. I need to increment current index. I never do that. So where do I need to increment that? I think right after I set x to equal it. Current index right here. Okay, I'll try not to be too happy. Let's see if it actually passes. Okay, great.